Space junk, one of the most serious issues in the world of astronomy. Space junk is unused satellites and other man-made debris in orbit around the Earth. Basically, metal scraps orbiting the Earth at rapid speed. I guess people weren't satisfied enough with polluting the Earth itself, so we moved on into space. Space junk is increasing in large numbers every year. This space debris has increased the potential danger to all space vehicles, such as the International Space Station, space shuttles, and other spacecrafts with humans aboard. More than 500,000 pieces of debris have been tracked and orbiting the Earth, traveling up to speeds at 17,500 miles per hour. At those speeds, a piece of metal the size of your pencil could go straight through your spacecraft and cause catastrophic damage. This is a video from NASA created to show us how the Earth has collected space junk throughout the years until 2015. As you can see, the amount of scrap surrounding our planet is quite disturbing. Collisions with the space debris are a serious problem for NASA. NASA created a set of guidelines on how to deal with each of these potential collision threats. These guidelines, part of a large body of decision-making aids known as the flight rules, specifying when the expected collisions of pieces of debris increase. Invasive actions or precautions will be made to ensure the safety of the crew. Debris avoidance maneuvers are planned when the probability of collision is greater than 1 in 100,000, unless it will result in additional risk to the crew. The safety of everyone aboard a spacecraft comes first before the mission. Space junk has become such a common problem, they have actually made movies about it, such as the newer released movie Gravity. While the story was fictional, the possibilities of hitting space junk are quite real. These guidelines I talked about earlier are essentially drawn as an imaginary box, known as the pizza box, because it is flat and rectangular shaped around the space vehicle. This box is about a mile deep by 30 miles across by 30 miles long, with the vehicle in the center. When predictions indicate that the debris will pass close enough for concern, and the tracking data deemed sufficiently accurate, Mission Control Centers in Houston and Moscow work together to develop a course of action. Sometimes these encounters are known well in advance, and there is time to move the station beforehand slightly, known as the debris avoidance maneuver, to keep the debris outside of the box. Other times, the tracking data isn't precise enough to warrant such a maneuver, or the close passing isn't identified in time to make the maneuver. In those cases, the control center may agree that the best course of action is to move the crew into spacecrafts that are used to transport humans to and from the space station. This allows enough time to isolate those spaceships from the station by closing the hatches in event of a damaging collision. The crew would be able to leave the station if the collision caused a loss of pressure in the life-supporting module or damaged the critical components. The spacecraft acts as a lifeboat for the crew in event of an emergency. Even though it takes very little movement in most cases to avoid debris, such movements with the space station require about 30 hours to plan and execute, mainly due to the need to use the station's Russian thrusters or the propulsion system on one of the docked Russian or European spacecrafts. Even with the thousands of pieces of orbital debris around our planet, it is surprising how few catastrophic collisions have actually happened. The people on the ground at NASA keep a very close eye on every piece of debris they can track and where they are at all times to ensure the safety of the crew in space. Many intelligent people do complex mathematics and tracking to figure out when, where, and what direction the spacecrafts need to move in order to miss space junk 24/7. One small mistake and you could have the lives of everyone on the space station at risk, or any other spacecraft. While most people look up to the astronauts, I personally think we should give more props to the astronomers on the ground, keeping the crew alive while they float around in space. In 1996, a French satellite was hit and damaged by debris from a French rocket that had exploded a decade earlier. On February 10, 2009, a dysfunctional Russian satellite collided with and destroyed a functioning U.S. commercial satellite. The collision added more than 2,000 pieces of trackable debris to the inventory of the space junk. One of the more idiotic cases of creation of space debris was in 2007 with the Chinese anti-satellite, which was the use of a missile to destroy an old weather satellite, adding more than 3,000 pieces of debris and problems. Scientists are trying to figure out ways to clear out space junk. Ideas such as putting giant magnets up into space to collect all the metal debris, nets to catch them with rockets attached to fling them out into space or into the sun, robot collectors, and more have been put onto the table. And as the years go by, they trial and error, but even with all of our attempts to clean up the space junk, we have gotten practically nowhere. The expenses to make these contraptions and send them into space, and to keep the gasoline for some of them to send them to where they need to go, are just way too high. For many people, the space junk isn't seen by their eyes, so it doesn't seem like it's their problem. They're not seeing the bigger picture, and they're not opening their eyes to the bigger problems. Space junk is a big problem, and it will continue to grow in our generation. It is our job as of now to figure out and how to solve these problems, cleaning out both our Earth itself and everything orbiting it. Thanks for watching, and I hope one day you all can come up with a great idea to help save our space.